All right, so let's take a look at different types of solids that we can have. So the first type of solid we can have is an ionic solid. An ionic solid. So an ionic solid is made of ions. Most popular example probably being sodium chloride, right? Table salt. Ionic solids in general have high melting points. They're very hard, yet brittle. So they're very hard, but if you smash them, they'll fall into like nice little crystalline pieces. And in general, they're non-conductive of electricity. So electricity is the movement of charge in a solid. These ions are not able to move, so they're non-conductive. But if you melt them down or dissolve them, they can conduct. Here's a picture of this. Right, so you can see the ionic solid, the different colors representing the different ions, right? One an anion, one a cation. Next up, we have metallic solids. So these are made of all metals. So it can either be the same metal or different metals, for example, copper, aluminum, iron, right? Or you can have alloys, which are a mix of the two. So if you think back to the kind of types of bonding, what we have here is metallic bond. And so what we kind of have is a sea of electrons with nuclei interdispersed there, right? So this is a metallic type of bonding. And so with this sea of electrons, these electrons are free to move about. And so metals generally have high electrical conductivities and thermal conductivities as well. They're malleable and ductile, which means that you can bend them, you can shape them, you can pull them into strings, that kind of thing. We'll just say can bend. And their melting point varies. Some have very high, some have very low. For example, mercury is a metal, its melting point is -39 degrees Celsius, whereas iron, also a metal, is 15,038 degrees Celsius. So you can see it can vary by quite a bit. So here's just a picture on the left. You can see some different metals. You can see they're nice and shiny. And then on the right, you can see this kind of sea of electrons, right? Where the electrons don't really belong to any one metal ion. After that, we have covalent networks. Or covalent network solids. And so these are solids made of infinitely bonded covalent, or an infinite amount of covalent bonds. So it's just a atom covalently bonded to another atom that's covalently bonded to another one and another one and another one and another one, so on and so forth. So that's probably my favorite type of solids. They're kind of the most interesting in terms of their electrical properties. That's probably a bit too advanced for this class, but here's just some examples of this stuff. So on the left, we have this sp3 hybridized carbon, right? So it's just carbon attached to carbon attached to carbon. This is the structure of diamonds. So diamonds super sharp or super hard, you know, see-through, that kind of thing. Here we have silicon oxides, right? So it's alternating silicons and oxygens. So this is glass. This is what all your glass is made out of, is silicon dioxide. Here, next up, we have carbon and silicon, right? That's silicon carbide, so that's kind of like fake diamonds. And then here we have carbon, but now it's sp2 hybridized. And so it forms these kinds of flat sheets. And so this is the graphite that you see in your pencil. These covalent solids in general have high melting points. And their other properties vary by a lot, right? So other properties vary. Some are extremely conducting, some are not conducting at all. It really depends on what you're looking at. And so that's why I think they're the most interesting, just because they're the most varied. And I spent a decent amount of my PhD work looking at some of these. And then finally, what we have is molecular solids. So in this case, these solids are just made out of a bunch of different molecules, and they're held together through the intermolecular forces we learned about, right? So made up of many molecules held together by intermolecular forces, right? And in general, these have low melting points, right? Because an intermolecular force is weaker than an intramolecular force, a bond. And so they generally have low melting points. So like CO2, carbon dioxide, if you ever play with some dry ice, that has a pretty low melting point. Iodine as well has a pretty low melting point. And then finally, here's just kind of a little chart that compares the different types of solids we've reviewed. So go ahead, pause the video, take a look at them. Think about the different kinds of solids you're currently surrounded by.